We're into 5.5. What we're talking about is a thing called compound inequalities. Lost my train of thought. That should be a D. So we've been doing inequalities for a while. What are the inequalities about? We'll make something be an inequality.
They're either less than, greater than, less than or equal to, greater than or equal to, or not equal at all.
All true. So those 5 signs get us things called inequalities. Today we're going to do a thing called compound inequalities, and there's 2 types. Some of the problems you're going to see the word and, other problems you're going to see the word or. Not really affecting your homework life, but just throwing it out there to educate you. The and questions are called conjunction problems. The or are called disjunction questions. But that's the only way I'd ever ask you that again would be maybe a bonus question or something. But the and questions are conjunction, or questions are disjunction questions. The first thing I'll ask you to do is graph. But before we even do that, let's think about the word and, think about the word or, and which word it is that is like the more demanding word. So imagine your mom, your dad, your guardian, whoever that is going on a trip, and before they leave you a list of things to do. Would you rather them keep saying the word and to you, or would they rather as you get this list of things to them to say or? You'd rather say or, because if they say or, you'd have a happy parent or guardian when they come home if you did
Both have
just one of those things. If they say clean your room, or clean the bathroom, or vacuum, or clean the garage, you're going to have a happy parent if you did one of those things because they said or. What if they said and? What's the way you're going to get a happy parent if your list is do this and this and this and this? You got to do all the things. And if you don't do all of the things, you're going to have an angry parent coming at you. So the and is a much more demanding word because you've got to do everything. The or is a little bit easier to go with because it's just like, hey, do this or do that. So if I ask you to graph the part of the number line where x was more than 3, let me just do that for now. If I want to say x more than 3, where are we on the number line?
3.
3, and everything to the right. Would you fill in that dot or no? No, because there's no equal. So not 3 itself, but like all of that stuff. If I just said this, where would you be? 10 include 10? Would 10 itself get included? Yeah. And also everything to the left, including some of the stuff we didn't want for the first thing. But if I say I want this and this, then what do we want?
Like 4, 5, 6, 7, 8, 9?
Yeah, we only want the stuff that's kind of like in the middle of that. Okay, so if we go to graph this, we would do 3 on the left, not because it's first, but because it's smaller on the number line. We would do 10 on the right, not because it was the second number, but because it was bigger. The greater than, we said we were or weren't including the 3? Weren't, so open dot. The 10 we are, so fill it in. And if we want to be more than the 3 and also under the 10, where would we be?
In the middle.
In the middle. So basically it's like first grade flashback and play a little game called Connect the Dots. Okay, the ands are generally going to be just like a little piece of the number line playing like Connect the Dots. So of the whole number line, we'd only want the stuff from 3 to 10 and nothing else. If we're this and that, that's pretty strict. Question about that? Usually you won't see them use the word and. You're going to see them do a different thing that I'm going to just call it a less than sandwich. You're going to see an X in the middle and then a less than on each side, where the variable is like the peanut butter and jelly or the bologna or the roast beef or whatever it is you eat in your sandwiches, I don't know. But we're going to get an X usually written in the middle of a couple less thans with the lower number on the left end, the higher number on the right end. And since this had an equal sign on it, that would have an equal sign on it. Instead of writing this big long thing, this is like a shorter way to write the same thing, but it does the same thing. If you don't see the word and, but you see a less than sandwich, in my made-up word, that's going to be this kind of a situation. That's called a conjunction. That's what we just did from there. So if you look right, you're going to see, here's a couple like less than sandwiches. Those are and wordings. I just didn't choose to use the word and. There is no way around the word or. I'm just going to have to use the word or. Question about the and part of life. What if we want to graph this one? If we want to go x greater than or equal to 4 or x less than 1. Think about this part, think about that part, and then if I say I just want you to have one or the other, what would you end up with the picture looking like? We'll start with the numbers. What number would you throw on the left?
1.
1, because it's smaller. On the right? 4, because it's bigger. 1's style?
Closed.
Open.
Open, because there's no equal to with the 1.
Close.
Fill in the 4, because we want it, because of the equals. And then if we're a winner, if we're either greater than the 4 or less than the 1, in what areas of the number line are we a winner?
Everywhere but in between.
Everywhere but in between. Everything to the right of the 4, everything to the left of the 1, not the part that's in between, that would be our losing territory now. But the 4 graphs usually look like 2 arrows running in different directions. So if all they're asking you to do is graph, think about it each time, but most of the time the and is going to be a connected dots. Most of the time the or is going to be an empty middle, but arrows go in 2 different directions. I'd say 99% of the time that's how that goes. Question about that? Here would be like a 1% thing. Let me say if I change this to be more than the 1 or under the 4. So if I went this way, this would get a little bit weird. If I'm more than the 1, that would have set me
4 1.
to the
4. And then you would have kept going.
right forever. If I want to go under the 4, that would head me to the left forever. We'd clip this open dot on our way, and we literally would end up with
Everything.
a whole number line, everything. What's your chances of being either under 4 or more than 1? Like, yes, like every time that's going to happen. And we hit the 1 zone twice. It's like a double win. So does it have to always go in these opposite directions? No, but like 99% of the time I'm going to say, yeah, that's how the graph's going to go. Question about that graph concept? Okay, solving, you probably don't even need me to be here to solve the ors. You just do each problem on its own. So if it says this or that, you'd solve this one. Turn or no turn? No turn. -7, because we're going to subtract the 2. Just remember to throw the word or into your answer. X, any reason to turn here? No. -2, because we're adding 3, that's where we'd end up. Do that problem, just don't forget to put the word or when you're done. Something about that. So do that again. So this one, what would you do first? A little bit more to do, 2 steps. Subtract the 3 would get you down to -15. Then divide the 5. Any chance of a turn?
-3.
No, because we're going to go, it is a negative involved, but it's not in the right spot. So that one's done. This one first. Subtract the 4, gets you down to -10.
Divide by 2.
Divide,
Flip the sign.
flip the sign,
+5.
+5, and we're almost perfect. Remember to just put the word in. Now we are perfect. Question about that. This you probably do need me just for a brief minute, but maybe not even, but if I gave you this, just this, what would you do? Subtract 8, both sides. If I gave you just this, subtract 8, both sides. I'm giving you this. What do you think you should do?
Subtract 8 everywhere.
Subtract 8 everywhere is correct.
Or subtract.
So we're going to do the opposite, not just to the one side or the two sides, but the all of the sides. We have like 3 zones to do. So when we subtract x at 8 in the middle, that's just going to leave an x. Subtract 8 here,
Negative.
and while you're at it, do the same there.
11.
And that's correct. We don't see a word there, but what word was that one?
Yeah.
That's an A. So this, to get the x completely alone, what are you going to have to do? Divide by 2, but divide by 2 everywhere. That would make this negative 8. It would make this 10. And then we'll need to get a camera turned from a friendly person in the front row. But anybody have a question about any of this before we start turning stuff?
Oh, I went the wrong way. Oh my goodness.
Go this way. It's all right.
Wait, which direction?
Cause an earthquake if you want.
I'm not a cameraman.
Capture those 4. Are we okay?
Yeah, I think so.
Okay. Quick question from the previous. Yeah.
Say you had a negative 2x instead of positive, would
Yep.
you just swap all the signs?
You would swap all the signs. Yeah, that's a great question, and that's going to happen to us over here. But yeah, if we did on that last one, if we did have a negative with the variable, it would have turned both of them, and now you'd have what I would call a greater than sandwich.
Yeah.
The x in the middle, and they'd all turn. Any other questions before we keep rolling with these last 4? So this, what's our move? Subtract 4. So 3x is waiting. That makes this 24. This, we're down in the negative pit. Agreed. Get x completely alone. 8 when we divide. Negative 2 when we divide. While we're there, just a reminder, if we did want to also make a graph, and I'll look at the homework in a minute, some they'll want a graph, some you'll want to solve, some they might want both things. Who would we do on the left-hand number? Negative 2, not because it's first, but because it's smaller. 8, we'd set these up. Would we fill in either thing? No, because neither had an equals. And then if an x is between those numbers with the less than sandwich, we'd want to connect the dots. About that. 2 options on this. Anybody have a first thought? There's 2 perfectly correct thoughts.
Distribute.
Distribute would be fine. So 3x plus 15 goes with this stuff. Subtract 15, so 3x weights. 6.
3. Negative 3.
Negative 3. Then 6 will be a 2, because what are we doing? Dividing.
1.
Negative 1, and that's a win. Question about that way? It's probably the most comfortable way. Shorter way? Instead of distributing the 3, we can divide. Divide where?
On both sides.
Both sides, everywhere. So we could make this a 4, leave this an x plus 5. This would turn into 7. Then all we'd have had to do is subtract 5. 7 subtracts 5, still 2. 4 subtracts 5,
-1.
still -1. Both paths are correct, not one that's right, one that's wrong, whatever you want to do. But if you can divide instead of distribute, as long as you can do it everywhere, that's maybe shorter. Well, it is shorter, but you don't have to do it that way. Something wrong with that. This one's designed to trick you. Subtract 6 is correct. Most people will see the 6 and see the subtracting and think, I should add 6. But if you added 6, it wouldn't kill this 6. What would adding 6 do to that? It'd make it a 12. So we're looking to subtract 6. Who's left in the middle then if you subtract 6? A negative with the x that's locked together. So we're going to subtract 6, leave the negative in x weight. This would be 1 once we subtract 6. This, it'd be -11. And now we have a little bit of a crisis. Crisis is too strong of a word, but so what weirdness to this? Where to go now?
Divide by 1.
Close.
-1.
Divide by -1. There's an invisible 1 there, so we'd want to divide by -1 so that the x is completely alone. So divide by -1, Divide by -1, it's 11.
Switch this.
Switch all the signs. Because if we left the signs go, this would be telling us that which number is bigger than which number. The -1, alligator wants to eat it instead of 11. -1 is not bigger than 11. That's pretty crazy. We divided by a negative. Anytime we divide by a negative, we need to flip the signs. If I wanted to do a graph, who would go over here? -1 because it's smaller. 11 because it's bigger. This is still telling you that x is in between those numbers, and I'd still connect the dots. This is saying x is under 11, so we're keeping under 11. This is saying x is more than -1, we're staying to the right of the -1. That's still the same kind of graph that we did. So instant replay of that, if I just want to turn this into a positive x, another way you could think of this is, basically you just have to switch all the signs. That would make this be 2 greater, -3. If there's a negative with the x, the signs are just going to all turn around. That's where we are. Question about any of this stuff from 5.5 business? So where we are is 205. 205. The directions say graph, and I'm going to then just change the directions on you. For 1 to 12, I'll say graph them. 1 to 12 are going to be like the first two we did where we graphed. Just graph them. The variables are already all alone. Just graph them up. Starting on 13, going to 26, I'll say you don't have to graph anything. Just solve them. There's some ands, there's some ors. There's more of the ands than the ors. But up from 13 to 26, just get an answer that looks like this. Okay, so 1 to 12 answers look like this, because there is no solving even to be done. They're going to give you at the beginning something like that. Just make the graph. But starting at 13, do the solution to get the x alone, but don't graph anything. So 1 to 12, graph only. 13 to 26, solve only, stop graphing, and that's our day. Shut that on down.